Hey, this is Mr. Beckstrom, and today I'm going to go over section 7.2. This is on the inverse trigonometric functions, and I've got a couple of examples, 3 to be exact today. This is very similar to the last thing that we did in section 7.1, except this time we're combining different trigonometric functions together. So before we had like the inverse cosine of the cosine of some value, and this time we're going to be mixing and matching trigonometric functions together and see how to solve those. And it's going to be solved differently. So let's take a look at these three here and see how we do those. So you all know how I like to do them. I like to do triangles, and we're going to do triangles here as well. Now all three of these, we could actually do these in our calculators as well, if you have the graphing calculator. Now remember, the graphing calculator is great until it gives us an answer that's a square root. So if you have an answer that is, for example, pi over 3, it's going to give you some decimal approximation for that. And if you don't know that that's pi over 3, then you might have an issue there. All right, so let's take a look at how we would do this with triangles. So we've got our unit circle here. It's going to be important to know that we know the domains of our inverse trig functions. So let's do the first one. So for cosine, the domain is going to be between 0 and pi. That's the top half of our circle. So it's either going to be the first quadrant or the second quadrant. Notice that my value is positive. That's going to restrict it to the first quadrant. So that's where I'm going to make my triangle here. So here's my triangle. That's my theta here, my acute angle theta, and cosine is adjacent over hypotenuse. So the adjacent side will be the square root of 2. The hypotenuse will be 2. And then we can figure out the last side by using the Pythagorean theorem. So square root of 2 squared plus b squared is going to be equal to 2 squared. And we can solve that. So that's going to be 4 minus 2, which is going to be 2. So b is going to be the square root of 2 as well. So now, once we found that out, this is how we set up the inverse cosine there. The tangent of that same angle there is just going to be, according to SOHCAHTOA, the opposite over adjacent. So that's going to be the square root of 2 over the square root of 2, which is going to be equal to 1. Now, if we check that in our calculator, 1 is not an irrational number, so we should actually get that. All right, we can probably put this in as one function or do it separately. Let's try to do this as one here. So the tangent of the inverse, the tangent of the inverse cosine of the square root of 2 divided by 2. Close parentheses, and sure enough, that is 1. So, good way to check that. All right, let's take a look at the next one here. Notice for this next one, we have the same setup here. So, same triangle and same 3 sides, so we don't have to do anything there. But instead of the tangent, we have the secant. So, I don't have to change anything. I just have to do a different part of SOHCAHTOA. So remember, the secant is the reciprocal of the cosine. So if the cosine is adjacent over hypotenuse, the secant is hypotenuse over adjacent. So that's just going to be 2 over root 2. So that's just going to be 2 over root 2. And MyMathLab will actually take it just like that, so you can leave it like that. If you wanted to rationalize the denominator, you could do that as well, just by multiplying both the top and the bottom by root 2. So that'll give you 2 root 2 over 2. which just reduces down to root 2. So either one of those will work just fine. So either 2 over root 2 or root 2. Okay, and then for this last one here, we have the sine of the inverse tangent of 1. So I'm going to go ahead and take these values out here. So let's figure out what quadrant we're in now. Notice I'm leaving the triangle there, and that's going to be for a reason. So the domain for the inverse tangent function is either in the first or fourth quadrant. Remember, that goes from negative pi over 2 to pi over 2, or from negative 90 to positive 90. Since the value here is positive, I know I'm in the first quadrant again. So all three of these happen to be in the first quadrant, but remember that we're usually either going to be in the first, the second, or the fourth quadrant, depending on which of the 6 functions that we have. I don't actually ever think that we're in this third quadrant here. So if we're over here, then if we're in the first quadrant here, we have the tangent function. Remember, the tangent, according to SOHCAHTOA, is opposite over adjacent. So that's just going to be 1 over 1. So I can just come over here and put a 1 over 1. Using the Pythagorean theorem, 1 squared plus 1 squared is equal to c squared. And that's going to give me the hypotenuse equal to the square root of 2. And this means that the sine of that is opposite over hypotenuse, 1 over square root of 2, 1 over square root of 2, which my math lab will take. So you can just leave it like that if you want to put it in there. Or you can, once again, rationalize the denominator, which is the correct thing to do. So you can multiply by the square root of 2 over the square root of 2, which gives you root 2 over 2. All right, I hope this helped. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.